Hello students, welcome to Block 9, Solutions. In this video I'm going to start discussing with you about the characteristics of acids and bases. Talking about acids, they are going to be characterized because they have a sour flavor, that flavor that you taste in your Sour Patches candies or a lemon or an orange. They're corrosive to the skin, which means that they can burn you. That's why it's important to wear latex gloves. They are neutralized by bases by the neutralization reaction, and they can also corrode metals, which means that they destroy them. On the other hand, for bases, they have a bitter flavor, which is the one that you taste in your cup of coffee. They are soft and corrosive, which means that they can also burn your skin. They are neutralized by acids by the same neutralization reaction, and they can dissolve fat. That's why bases are used for the production of soap. Examples of both of them, starting with the acids, we can find the ascorbic acid, better known as vitamin C, which is found in oranges, lemons, and lettuce. Then we have acetic acid, which is found in vinegar, most of the time in a concentration of 6%. Then we find carbonic acid that is added to some beverages so they can have that fizz. Then we have hydrochloric acid, which is inside our stomachs, ready to destroy all the food that we eat. The reason why the acid doesn't destroy the stomach is that it has a protective layer in it. But that's why it's very important that you eat your breakfast in the morning so the stomach is not alone and the acid cannot attack it. Malic acid is present in some fruits and also vegetables. Then we have tannic acid, which is the one responsible for the special taste of teas. Then we find lactic acid, which is present in dairy food such as yogurt, milk, etc. Then we have formic acid, which is the one produced by ants and responsible for the pain that we feel when they bite us. Examples of bases, we have some cleaning products such as ammonia, NH3. Then we have caustic soda, which is sodium hydroxide, and that in combination with fat can produce soap. Then we have calcium hydroxide, which is used for dentists to repair your teeth. And sodium bicarbonate, which is very widely used as cleaning product, for cooking, for whitening your teeth, and also as a deodorant. To measure if something is acid or basic, we have the hydrogen potential, which is better known as pH. This pH is the measurement of the acidity of the basicity of a solution, and it expresses the hydrogen ion concentration. The pH works with a scale that goes from the 0 to the 14, being the 7 the neutral. Below the 7 we find the acids, and above the 7 until the 14 we have the bases. It also is represented by a scale of colors that includes reds for the acids and blues for the bases. This measurement is done by the use of acid-base indicators. These indicators can either be natural or synthetic. The indicators are substances that can change color depending on the acidity or basicity of a solution. An example of a natural indicator is the extract of red cabbage or hibiscus. When they get in contact with an acid solution, they turn to the reds, and if it is a basic solution, they turn to the blues. Some synthetic indicators can be found, such as the papers, that are the pH indicator paper. Originally, it is yellow and it turns the color depending on the pH of the solution. This color is compared to the scale that is on the box, and then we can establish what pH it has. For the test papers, that are the Litmus Papers, we have two, one blue and one red. When the blue one is in the presence of an acid solution, it turns red, and when the red one is in the presence of a basic solution, it turns blue. We can also find liquid synthetic indicators such as phenolphthalein and methyl orange. Phenolphthalein was used, if you remember, in our experiment with sodium in water, and it turns pink in the presence of a basic solution. In the case of methyl orange, if you have an acid solution, it turns red, and if you have a basic solution, it turns yellow. These are only a few examples of what you can find out there. But if you want to make a more accurate measurement of the pH, then we can use a pH meter, which tells you precisely what is the pH that the solution has, with decimals and everything. Thank you for watching. See you next time. Bye bye.